Well, number 4 here, this limit kind of ties in with what we're doing here. If n is greater than 0, so if this exponent is positive, doesn't matter if it's a fraction, a decimal, anything, as long as it's positive, we take the limit as x approaches infinity of 1 over x to some positive exponent, our answer is going to be 0. Similar to number 4 up here. Works the other way as well, as long as 1 over x to the n is defined when x is negative. The limit as x approaches negative infinity of 1 over x to the n is equal to 0. Because think about this one, right? We have 1 over x squared. And we saw the table. As x gets bigger and bigger on the bottom, this whole fraction is just going to get really, really small, right? Even at 100, that's not a huge number. It's a really small decimal, right? That's going to be the same as long as x is positive. This same thing is going to occur. We get a really, really big number on the bottom and a really small one on top. So that's going to keep getting smaller and smaller, approaching 0 the whole time. Even if it was just 1 over x, same thing happens. Or 1 over x to the 1/2, same thing happens. And actually, thing that we want to keep in mind too, with some of the properties we've talked about before, even if there's a constant on top, we had the limit as x approaches infinity of c over x to the n. That's going to be 0 also. So even if we have a constant right here, that doesn't matter, right? We talked about this before with properties of limits, that c, we can kind of split this up. Limit as x approaches infinity of a constant is just a constant. But then we'd be multiplying by the limit as x approaches infinity of 1 over x to the n, which we know is 0. So this still ends up being 0, even if it's a number on top. Right? Even if this had like 100 on top over x squared, that whole fraction is still going to get closer and closer to 0, smaller and smaller. All right, so this is kind of some important stuff you may want to put on your My Review Guide, along with these couple steps on how to find the limits of a rational function at infinity. So with this, 2 steps basically. We're going to multiply the numerator and denominator by 1 over x to the n. And n is going to be the biggest degree in the denominator. Once we do that, then we're going to use the theorems above and those different properties and theorems we've talked about already to evaluate the limits of the resulting function. So let's go ahead and take a look at number 1. The biggest degree on the bottom is 2. So we're going to multiply the top and bottom by 1 over x squared. And as long as we're multiplying top and bottom by the same thing, we're not changing what this is equal to, we're just changing what it looks like. We're giving it a facelift. Alright, so we get the limit as x approaches infinity. Multiply 7x times 1 over x squared, we end up with 7 over x, right? The x here cancels out with the one of the 2 on the bottom. And then on the bottom, 2x squared times 1 over x squared, we're distributing this to both of these. We end up with 2 minus 5 over x. At this point, we're just going to use some of those properties we talked about earlier in the week where we can break this up into parts, right? I'm not going to physically write it out. Limit as x approaches infinity of 7 over x divided by limit as x approaches infinity of 2, and so on. I'm just going to kind of think of it in my head. I'm going to look at, okay, find the limit of this, find the limit of this, find the limit of this, and then do the operations afterwards. Yeah, so this should be 5 over x squared. But now we're just taking the limit of each part. So if we take the limit as x approaches infinity of 7 over x, so like I said earlier, even if this is a constant, over x to a positive degree, it doesn't matter if there's a constant up there, it's still going to be a limit of 0. Right, as x gets bigger and bigger, this fraction is going to get smaller and smaller, closer and closer to 0. Then we have the limit as x approaches infinity of 2. Right? Limit of a constant is just that constant, so we get 2. And then limit as x approaches infinity of 5 over x squared. We have a constant over x to a positive degree. That's going to be 0. Right, so then we end up getting 0 over 2, which is 0.